a line through the point of intersection of two lines. So let's say L1 is A1x plus B1y plus C1 is equal to 0, and let's say L2 is A2x plus B2y plus C2 is equal to 0. Now let's multiply this with a real number k. So L2 will become k times A2x plus B2y plus C2 is equal to k. Now let's add L1 and L2. We get A1x plus B1y plus C1 plus k times A2x plus B2y plus C2 is equal to 0. So, or in short, we can write it as L1 plus k L2 equal to 0. Now, this is a linear equation in x and y. So therefore it represents a line. Now let's say the point of intersection is x1 y1. Then the line L1 passing through this point can be written as A1 x1 plus B1 x1 B1 y1 plus C1 equal to 0, and L2 can be written, because that is also passing through this point of intersection, can be written as A2 x1 plus B2 y1 plus C2 equal to 0. So which means another line passing through the intersection of these 2 points, because remember this is the equation of the lines passing through the point of intersection of these 2 lines. So another line can be written as L3, which is also passing through this x1 y1, can be written as A1 x1 plus B1 y1 plus C1 plus k times A2 x1 plus B2 y1 plus C2 is equal to 0. Now as we have seen before, this is nothing but the equation of a line through x1 y1. So to figure out the equation of a line passing through the intersection of 2 other lines, we just do this. Now even if we multiply both L1 and L2 with 2 real numbers, what do we get? Let's say k and m. So KL1 plus ML2 equal to 0. Even if we do something like this still boils down to the same thing, because if we divide it by k, so k will disappear here and this will become m by KL2 equal to 0. And we can say L1 plus NL2 equal to 0, where n is equal to m by k. Okay, so that is as far as the equation of a line through the point of intersection of 2 lines is concerned. But suppose we are given 3 lines, right? We already have 3 lines and we have to figure out. Now here I have drawn the diagram, but suppose you are not given the diagrams. You are given L1 is L2 and L3 is given. So A1x plus B1y plus C1 equal to 0. L2 is A2x plus B2y plus C2 equal to 0. And L3 A3x plus B3y plus C3 equal to 0. The drawing is not given to you. In any case, this is just one example. But if you are given these 3 equations of 3 lines, how will you figure out whether they are passing through the or intersecting the same point? or at the same point. Okay, so let's take it step by step. Now let's say point of intersection of L1 and L2. Remember, we already know how to figure out the coordinates. Remember that x, y and 1, b1, b2, c1, c2, a1, a2 and b1, b2. Cross multiply. So our coordinates of the point of intersection would be b1, c2 minus b2, c1 by a1, b2 minus a2, b1, and y coordinate will be c1, a2 minus a1, c2 by a1, b2 minus a2, b1. Okay, so we have got the intersection of L1 and L2. So basically coordinates of the intersection of L1 and L2. Now we have to figure out for third also. So given that this point of intersection, this one, lies on the third line, that is L3 can be written as, just now we have seen before, A3 B1 C2 minus B2 C1 by A1 B2 minus A2 B1 plus B times C1 A2 minus A1 C2 by A1 B2 minus A2 B1 plus C3. This should be B3 is equal to 0. Okay, let's multiply this entire thing by A1 B2 minus A2 B1. So what do we get? A3 times B1 C2 minus B2 C1 plus B3 times C1 A2 minus A1 C2 plus C3 times A1 B2 minus A2 B1 is equal to 0. So this is the condition that has to be satisfied. So by just using the coefficients and substituting it, if we get the answer as 0, that means the three lines are intersecting at the same point. Now this condition, if satisfied, we can say that L1, L2, L3 are concurrent. Concurrency means pass through the same point. So that is equation of a line through the point of intersection of two lines and concurrency of three lines. That's it for now. Bye.